Alright, hey everyone. Right now I'm recording this on Monday morning because I'm afraid if I record it any later I'm not going to feel like it because right now I'm not feeling super hot and everyone in the house isn't feeling super hot. So if you would be praying for our family, that would be very much appreciated. But this is another virtual learning lesson for Algebra 2. So this time we are talking about something called special functions. Special functions are a little bit different than the functions we typically work with. We have special functions such as greatest integer functions, absolute value functions, and then we're going to, after learning about those functions, we are going to learn what piecewise functions are, which are multiple function rules within one particular function. So there is a bit of content in regards to this particular section, so make sure that you have your notes out because we are going to go through all of the notes today. So go ahead and pull out your notes for these different types of functions, special functions. I believe these are your day 22 notes as far as I know. So go ahead and pull those out before we get started, okay? Whoa, that was slow. Alright, greatest integer functions. So the greatest integer function is this particular function right here. And what this function does is it returns the greatest integer that is less than or equal to x. So, the greatest integer that is less than or equal to x. What does that mean? So, if you have a rational number such as 4 over 3, the greatest integer function will return the greatest integer that is less than 4 over 3. So that means the integer less than 4 over 3 would be 3 over 3, which as an integer is 1. Alright? So that's what the greatest integer function represents. So your domain can be any real number, but the range will always be an integer. You'll always get an integer for the greatest integer function. So let's say for this function, x equaled 3.14, the pi number. If it equaled 3.14, what you would get for y or f of x would be 3, because that is the next integer that is less than this number, okay? So y will always be an integer for the greatest integer function, all right? So down here, this is an example of a graph of a greatest integer function. So anytime x is between 0 and 1, for example, the next lowest integer would be 0. And that's why for anything between 0 and 1 where x equals, y is always equal to 0. Okay? So right here your y value is 0 right here. Where your x-axis is, that means y equals 0. Everything between 0 and 1 for what x equals, y is equal to 0. Hopefully that makes sense, but that's how the greatest integer function works. So anytime it's between 1 and 2, you have y is equal to 1. Okay? Now notice here, you have a closed circle on the left side of your greatest integer function and an open circle on the right side. Why is that? Well, remember, the highest integer here goes up to the next group. Because if you have 2 or higher for your x, your y will be equal to 2 automatically. So it's just going to jump right up to 2 whenever you go to 2 for x or higher. Ooh, excuse me. All right. So this is the greatest integer function. All right? Wow. COVID's no fun. Let me just tell you that. All right. Special functions notes. So this is these are from your notes here. So this is just reinforcing greatest integer functions because this is a brand new topic to me as well. So explaining it to you, I had to go through quite a bit of things myself. All right. So greatest integer function returns the greatest integer less than or equal to x. That's what I said back on the previous slide. All right. So the set of real numbers, your domain will be your set of real numbers. Okay. So any real number is eligible to be an x value. But every y value will be a set of integers, so your range, all right? So f of x is equal to x. This is the actual function itself, okay? And this is how the function will look if you were to graph it, all right? So these brackets here represent greatest integer, okay? Greatest integer. All right, so now we're actually going to find some values. So if we evaluate f of x is equal to x, the greatest integer of x, we have these four values here, and we are going to figure out what they are, okay? All right, so if we have f of 2, the greatest integer of 2 will just be 2, okay? Because remember, if x equals 2, what does y equal? Y also equals 2, if you can see it on the graph there as well. All right, let's try 3 over 2. So 3 over 2 would be right here on the graph. What would that equal? 1. Because y value is 1 there, okay, right? Remember, it's always the next integer that is below your real number, okay? So negative 2 over 3 for x would be over here. So that means your greatest integer, or your next integer down, will be negative 1. But hold up. Negative 1 appears to look greater than negative 2/3. Actually, it's not. Remember, negative 1 is less than negative 2/3. So the next integer that's less than or equal to negative 2/3 is negative 1. And then for negative 5, it's the same thing, negative 5. All right? That's how the greatest integer function works. You can always rewind the video if you have any questions regarding it. If you have questions that weren't brought up in the video, email me, text me, whatever you need to do, because I will be available. I will try to get a response to you. All right, next up, absolute value functions. An absolute value function is a graph that maps a given x value to its distance from 0. Remember, absolute value represents a number's distance from 0, and absolute value is always positive. All right? It's always positive. So how does that represented in a graph? So take a look at this graph here. F of x is equal to the absolute value of x. It is the most commonly used piecewise function. We haven't talked about piecewise functions yet, but this is related to piecewise functions, okay? So absolute value function. We start at 0, and then remember the distance from 0 here is 0. What if x equals 1? X equals 1. Plus or minus 1, let's say that. What if x equals plus or minus 1? If we plug in plus or minus 1 here for x, we always get a positive 1 for y. Notice that? So that's where it comes in that absolute value is always positive. If x equals negative 3, so my negative 3 is right here, y is equal to positive 3. Okay? So it's just like drawing out a t-chart and coming up with the different values. You can always draw a t-chart if you're confused on how to graph these, but I'm going to show you a much quicker way right here to graph these absolute value functions. I'm going to show you a much quicker way. But if this method that I'm about to show you confuses you, just use a t-chart. Okay? T-chart will always give you assistance in making these different graphs, okay? So, absolute value function. This is what all absolute value functions will look like, but sometimes they'll translate to different locations on the graph, and we're going to talk about that right now. All right, so graphing absolute value. Remember, these graphs here are still in the format y equals mx plus b. All right, they're still equal to y equals mx plus b, and this will be related to the quicker way that we can graph these in just a minute. All right, so g of x equals the absolute value of x plus 3. So let's see. Let's draw up a graph. And when you're doing absolute value functions, it's always good to do -1, 0, and 1, because that will give you an idea of where that v that comes up with absolute values will be. All right? So -1, absolute value -1 is 1, plus 3 equals 4. 0, absolute value of 0 is 0, plus 3 gives me 3. 1 plus 3 is 4. So that means my vertex is on the y-axis. So 0, 3. Let's plot my points here. And then I draw my graph. Just like that. All right. So you can use the t-chart, but one thing to notice here, let's go back to slope-intercept form, y equals mx plus b. What's 3? 3 is my y-intercept. And look where my vertex ends up on the graph. Ends up at 3. So I need to find my pointer again. There it is. All right, so one thing you can point out in regards to graphing these is if you have a number sitting outside of the absolute value symbol, that is most likely going to be your y-intercept, okay? So if you know where your y-intercept is, you can just start with that point and then draw a v just like this. Because all absolute value inequalities have this same type of format. Every time your value increases by 1 for your y and 1 for your x. All right, every time. And we haven't talked about the spread of data just yet. That's not going to come for a long time, probably not even until you get to pre-calculus. So absolute value inequalities always have this format. All right, and then for example, you have h of x equals x minus 2. All right, absolute value of x minus 2. So t-chart, you have x minus 2. So let's do 1, 0, -1 again. So x minus 2. So 1 minus 2 is -1. Absolute value -1 is 1. 0 minus 2 is -2. Absolute value is 2. -1 minus 2 is -3. Absolute value gives me 3. All right, so let's graph that. 0, 2, 1, 1, and -1, 3. Something is not right here. -1, 3. Oh yeah, that's right. That's right. All right. So we draw our graph. Remember, if you don't have points on this side, the format is the same. It just increases by 1. Format's always the same. And this would be your absolute value graph. Notice here, you have -2. Inside the absolute value, where is my vertex? It's in positive 2. It's at positive 2 on the x-axis. So if you have a number here within your absolute value symbol, this number will map to the opposite point on the x-axis. Okay? Opposite point on the x-axis. That's going to be key to graphing these a lot more easily than just using a t-chart and going through all of the math. You can make it a lot easier for yourself if you know this quicker way of determining absolute value graphs. All right, so this is the format for an absolute value graph. It's similar to y equals mx plus b. K is still your y-intercept, okay? K is still your y-intercept. H is, oops, just look that up real quick. H represents your horizontal movement. I knew it was something like that. Horizontal movement. So H is the horizontal movement along the x-axis. Your K is your movement along the y-axis. So if we were to graph this, what would it be? First off, look how it's a minus H. If we have a plus 3, where would that map to on the x-axis, since we're starting with a minus? It would go to negative 3. Alright? So, first step is determine your horizontal. So if it's a plus 3, that means it's going to map to the opposite. Your vertex is going to map to the opposite point on your graph. Okay? Alright. And then let's do our y-intercept now. Our y-intercept's negative 3. This is a plus k, so it's going to go in the same direction as indicated by the sign. So we're going to go down 3. My vertex is right here, and then it goes whoop, whoop. And I know that's not perfect, but it's very close to what we would typically see. All right? So all you have to do is determine your horizontal value plus 3, map the vertex to the opposite for the horizontal, but not to the opposite for the y-intercept. You have to go down, since it's a negative for the y-intercept. But for the horizontal, you go the opposite direction. Okay? Then you just draw your v. That's pretty much all you have to do. Alright? So that's the absolute value function. Alright, so real quick, I want you to write this function rule. Okay? Alright, so if I look at this, remember my format x minus h plus k. So if I'm going 1 to the left, that means I'm going to use f of x instead of g of x, but that means my absolute value, my number within the absolute value is going to be the opposite of where this is going. It's going negative 1, so that means x plus 1. Okay? Alright, and then on my y it goes down 2, so it'll be the same, minus 2. That's how you draw those. Okay? Makes it a lot easier than using a t-chart. Alright, so this part is where things get a little interesting. We're putting functions together, or function rules together. So a function whose value is defined by different expressions for various intervals of its domain is called a piecewise function. You saw some of these at the very beginning of this chapter when we did that activity on Desmos. So this function here has 3 different rules attached to it. Okay? So if x is less than negative 2 for your domain, your y is going to map to x plus 3. So let's test that out real quick, okay? We just have different rules applying to different numbers within the domain. That's what we have here. Right here represents your domain. So everything less than negative 2 on your domain, your range will be x plus 3. So this is your domain here, and this is your range, okay? So your range depends on if this value for your domain exists, okay? So we are going to start off with negative 2, negative 3, and negative 4, all right? So if x is negative 2, y equals 1, because negative 2 plus 3 is 1. Negative 3 plus 3 gives me 0, and negative 4 plus 3 gives me negative 1. Alright, so that is your first function rule, and that's how you can indicate that function there. Now we have another function, okay? So this function here, I'm going to get a different color of ink. This function over here, you have negative 2 is less than or equal to x is less than or equal to 2. So any number on the domain that's between these, any number for your x that's in between these two values will be squared. Okay? So let's do that real quick. Remember, this is your range, and your range depends on what your domain is or what your x is. Okay? All right, so let's do that real quick. X, y. All right, so -2, 0, and 2. Hopefully you can still see that. All right, so if -2 squared is 4, -2, bingo. And then 0 squared is just 0. So there. And then 2 squared again is 4. So we have what is known here as a parabola that we created, but it's limited between -2 and 2. So it stops there. And remember, the equals sign, you have your closed circles. For your signs without an equals, it would be an open circle. So this means here, no matter what your domain is between 2 and 5, your range will be 1. So you just have a straight horizontal line across. Okay? So whenever you have a horizontal line, you just put the value for y. Okay? So piecewise functions can take a little bit to figure out, to understand, but hopefully this breakdown was a little bit beneficial to that purpose. All right, so next up, state the domain and range of each of these different piecewise functions, okay? Look here. You have that v, right? So that means you are going to have an absolute value inequality, okay? So this is just asking you to state the domain and range. It's not asking you to write a function rule. So all you have to do is figure out for the domain, so our domain's going to be in blue, we have our x values. All right? So x such that -4, because it starts at -4, is less than or equal to, because it's a closed circle, less than or equal to x is less than or equal to 3. Remember, we did these at the very beginning of this chapter. The range, so your range will represent, let's see if I can change the color of it. Your range is anything in between here and here. Okay? It's anything between here and here. So your range would be y. I don't understand why they didn't give you much room here. Y such that 2 is less than or equal to x is less than or equal to 6. Okay? So that would be your range. All right, your domain. For this one, I'm going to let you guys do this one on your own real quick, okay? All right. So, your domain for this one is x such that, they start with x such that, -1, 2, 3, 4, 5, 6. So it starts here. -6 is less than or equal to x is less than or equal to -1. Now this is probably where you got stuck, because how do you account for the gap? Well, remember, you could just make it into a disjunction. You could put or 2 is less than or equal to x is less than 4. Excuse me, 4. Because you have an open circle here, it's just less than. And then your range is just y equals 4. Because remember, your range is this line and this line, because you just have these two lines here. Y equals 4 or y equals 2. So for these ones, for ones that are separate, you'll have to just put an or in between to indicate the separate domains and separate ranges. So these are your domains and ranges. Alright, so try and state the domain and range of this one real quick. Alright, so domain, so our domain is, oops, I need to erase that. Oopsie. Alright, so remember our domain starts here, ends here. Now this number is still included in the set despite the fact that it's part of a different line, so we can include that. X such that -4 is less than or equal to x is less than or equal to 5. Because all of this is part of your domain, okay? Part of your x values, your set of x values. Now let's take a look at your range. We're going to get a different color for your range. Your range, your top value is here, and your bottom value is here. You look at the horizontal lines for your range. So we don't have to worry about this line here compared to this line because all the values of the range for this line include the values of the range for this line. So we can just write the top value here and the bottom value down here. So y, we're going to start off with our lowest value, so -3 is less than or equal to y is less than or equal to 2, 3, 4, 5, 6, 7. So that is how you state the domain and range of a piecewise function, okay? I noticed I made a little bit of a mistake somewhere. I'm going to mark that and erase that. I added an equal symbol to a spot where there is no closed circle. So be careful about that. That can be very easy to do in any particular situation. So, alright, write a piecewise function rule describing the graph. So in this particular case, we are actually writing the piecewise function, or the rules for them. So x plus 4, so remember how I broke this down. So this is your range, and these 3 blanks here are your domain. So again, it comes down to just finding the domain. And typically with these piecewise functions, your lowest values on the x-axis will be first in this function rule. So we're going to start off x plus 4 if -4 is less than or equal to x, then my line here is less than 2. Okay? So we've taken care of this line here. Alright? So we're going to grab a different color for this side. Alright, so our 3, so we can see what equals 3 right here, these two values. So 3 if -2 is less than or equal to x is less than or equal to 0. Okay? And then -3 over 2x plus 3 if this is true. Okay? So in this particular situation, what we would do, let me grab a different color here. So this line here is this function rule right here. So it is if 0 is less than or equal to x is less than or equal to 2. So for these types of problems, all you're doing is finding the domain that resembles these ranges, okay? So you got to determine, okay, what line represents x plus 4, or which one could possibly, and then you just write the domain for those. This is getting to be a very long, quite a long lesson. I might make it 2 days long because this is a long lesson. All right. Okay. So this one, graph the piecewise function and state its domain and range. So this time it's asking us to graph this and then state its domain and range. So first of all, -3, if -5 is less than or equal to x, is less than -2. Remember, this is our range. So if we know that our range, no matter what these numbers are going to be, is -3, then we can easily write this, okay? So here's how we figure this out. -5, we start for our x-axis, 1, 2, 3, 4, 5, and then it's going to be -3. So it starts off with a closed circle, and it goes back to -2. And this is an open circle. And I just realized this is -5. Oops. Alright, so that is our line right there for this particular function. Because remember, we have our domain and we have our range. Okay? Alright, x plus 1, if -2 is less than or equal to x, is less than 1. So that means if x equals -2, -2 plus 1 is -1. So if x equals -2, -2 plus 1 is -1. So that means we start here. Okay? And then, what about 1? Let's try 1. If it's less than 1, 1 plus 1 equals 2. And this is an open circle over here. So you can honestly just use your 2 endpoints here. So you have one endpoint here and one endpoint here. Graph those points and then connect the dots. So we have our second line right there. And then lastly, -x plus 4 if 1 is less than or equal to x is less than or equal to 4. So if x equals 1, let's substitute 1 in for our x here. 1 in for our x. So -1 plus 4 gives you 3. So that means we start right up here. Okay? Alright. And then 4. So 4 negative is -4 plus 4 gives me 0. So x equals 4. Y equals 0. Oops. Yeah, that's right. And then it just comes down to, once again, to connecting the dots. So here is how you do this. First off, find endpoints. Find endpoints, okay? And I am doing a very poor job of writing. You find your endpoints and then connect the dots. Remember, your endpoints are these two values here. That makes it pretty straightforward, okay? So you just find your endpoints and connect the dots. So you substitute -2 in for x. -2 plus 1 gives me -1. 1 plus 1 gives me 2. Connect the dots. That's what we did for this line here. Alright. Try this one on your own. I'm not actually going to solve it for you. I'm going to actually just let you take a stab at this yourself. This one's not too bad. Alright. That took a while. Section 2.5 is complete. So, go and Google Classroom will have your homework assignment published up there. If you have any questions, remember, you can always send me an email, or you can either text me or just get in contact with me in some way. Alright? Okay. Hopefully that video was helpful to you, and I will see you guys hopefully soon.